Hello and welcome back to the second video in lesson 17. I'm going to talk about correlation coefficient. So you're going to see I have a bunch of formulas here and I'm going to talk about them very briefly because again, you can always Google these formulas. It's not like they're top secret information. I'm more focused on our interpretation, so we're going to have the spreadsheet do a lot of this work for us. In fact, we're going to have it do pretty much all the work for us. So this formula, so we're looking at, in order to numerically tell us the strength of a relationship or the correlation of the data, we use the formula to determine the covariance. That's what this formula is. It's determining the covariance or the relationship between X and Y, and that's what that SXY stands for. All right, so that's your standard deviation of X and Y, so in a comparison together. All right, in that formula then you have X, which is again your data point, your X bar, which is the mean of X values. You have your Y, which is data point. And that is your dependent value. All right, from your X. Y bar is your mean of Y values. Okay, and then you also have an N there. That's number of data collected. All right, a lot of those variables, self-explanatory after we've done those previous lessons as far as the X and the X bar go. Okay, so old days you'd have to figure out all this information by hand, plug it in. The spreadsheet's going to take care of that for us, but we have to understand kind of what it's doing. So the correlation coefficient, or R, all right, so that is your variable for the correlation coefficient, is then calculated using the following formula. So we have R, our SXY, so that's from above. So that's the standard deviation of, X and Y together. Then we have the standard deviation of X, and then we have the standard deviation of Y. So a whole lot of work, and you know what? We could calculate each of these individually. Spreadsheet would do it for us, but the point here is why would we do that? So R, again, that is our correlation coefficient. All right, so again, our focus, the reason I don't have you actually using these formulas by hand is because in this course, I want you to be able to interpret the results in the data. So I'm not worried about the actual process of you calculating everything. I'm worried about you being able to tell me the significance of the value that we get. All right. So just to give you a scale here, this line here, I'm going to give you a scale to feel, what's our range for our values. So our values are always between negative 1.0 and 1.0. So I'll put that up here as well. So from negative 1 R to positive 1 is your range for your R values. You're never going to get that outside of that range. In the middle, obviously you got a value of 0. And then I'm going to increment this into thirds, okay? So here we'll have 0.33, 0.66, go in the opposite direction, negative 0.33, negative 0.66, so a third and 2/3. And the reason for that is as follows. If you get an R value equal to 0, we say there is no relationship, all right? It tells us absolutely that there is no relationship there, okay? If you get a number between 0.333, you are getting a weak relationship. And that goes for both directions here, okay? So as a note, I'll do that down below. Number indicates strength of relationship. And the sign, positive or negative, that indicates slope of line. All right, so going back here then. So we have weak. If you get between 0.33 and 0.66, we call that moderate. So there's a moderate relationship between the data. And then if you are in the outer range, we say it's a strong relationship between the x and y variable. All right. We call the positive values a positive linear correlation. So if you get an R value of plus 0.7, we say it is a positive, strong linear correlation. If we go the other direction, we are calling that a negative linear correlation. So all the positive and negative is doing is telling us the slope of the line of best fit, really. Okay? So there is a negative line in terms of slope, there's a positive. So it's okay to get negative values. All right, it still means it is linear. It's that number that indicates the strength. So 0.7, negative 0.7, and so on and so forth. All right, so I'm going to move on to the spreadsheet part of the example here. So the first example, farmer wants to determine whether there's a relationship between the mean temperature during the growing season. So that's my first column, and the size of his wheat crop. So an application in terms of if you're looking at going into agriculture, looking at working for seed companies. We want to determine the correlation of the data. So is it a positive, is it a negative, strong, weak, and so on and so forth. Then I want to determine the correlation coefficient, then talk about the conclusions. So I've already entered the example into the spreadsheet. If you pull up lesson 17, you can work along with me. What we're going to do is we're going to create a scatter plot. That's how we determine how we can analyze our data. So we grab all the information here and we go and we want to insert a chart. Okay, so highlight the data with titles, insert chart, and we get this screen right here. I want to pick a different type of graph because they only give us bar and line graphs at this point. So I'm going to go more, and there's what we want. We want scatter plot all the time in this course. Okay, scatter plot, and here we go. Okay, so then we go to customize because we want to put our titles in. So we'll go temp first yield. I'm going to keep it simple just for timing. Okay, the legend on the right, and you can scroll down. There's a whole bunch of stuff that we can put on here. So temperature, that's in C. Actually, we'll just put its mean temperature, so leave it there. I want the minimum. I want it to be 0, and I want it to go to 15 because I want to see what the y-intercept is. Okay. Continuing to scroll down, you can put grid lines on if you want. It's up to you. Okay, looks like that maybe. It's up to you on what you're looking at. We want a default scale. I'm going to do it in color. Now, we want to add a trend line. Oh, if you go up, sorry, axis, see how you can pull down and we can go the vertical? I put a title on there. All right. So there's the yield. All right, so you put everything on there. The important thing is scrolling right down to the bottom and looking at trend line. And we're going to go linear at this point. So here is, this is the spreadsheet's line of best fit. It says this is your line of best fit. Okay. So right now, if you were to look at this, so the light blue is your trend line. Okay. When I look at that line of best fit, I'm going to say, based on my observations, it is a weak positive relationship because the data points are a fair distance apart. Okay, so I'm just going to come back here for 1 second based on observation. I'll just type that in. So we'll go A based on observations. The correlation is a weak positive correlation. Not the best English, but that's what it is. So that's all you're looking at. You know, is it a positive slope, and you grade the data as strong or weak. Okay. Next, the question wants us to find the correlation coefficient. So we actually have to calculate that out. So it's right here. Now, you got to be careful. It's our squared value. So we're going to have to take the square root of our value. Okay. So you click that button, and here it is over here. There is our correlation factor. All right. So that's all we need. We're going to insert it, and I'm going to move it over so it's not sitting on top. And there's the information we need. So it gives us our trend line, and it tells us our correlation factor. All right, so we want R value, okay? So the R squared value is 0.218. Now we want the R value, okay? Oops, R value. So we got to go equals, and I'm going to go SQ. We want square root of that value. And you do this with the calculator. You don't have to use the spreadsheet. And we get about a 0.47. Okay, so 0.47, that means it's in the moderate range. So we were a little light on that. Okay, but we were in the right ballpark. We weren't too far off. So for, oops, try this again. So type in this answer up. So for B, the correlation coefficient was 0.47, which indicates the data has a moderate relationship. So we were a little harsh with the weak part, okay, but it gets us in the right area. So to finish this off with C part, so what conclusions can be made? Okay, oops, so as we make our conclusions here, so we can say there is a moderate relationship between mean temp and yield. Okay, that's apparent in the numbers. That tells us that's true. However, it's not a perfect relationship. 0.47, it's still not what we call in the high end of the moderate. It's still at the low end. So what we can say that there must be, or could be, either wording I would accept, could be other factors to consider as the relationship is only moderate. All right, and that's typically the case. If it's not a perfect relationship, 0.47 is on the low scale, then there's probably other factors that must be playing an influence on this particular situation. So it's important that I see that you identify that that is the case. Okay, now the textbook, most of the examples are probably going to come out to be 0.9 to 1 because the textbook doesn't want to stray too far from the obvious. But when you work with some of my journal questions or some of the homework question or some of the quiz questions, you're gonna run into situations where I'm going to ask you to make some type of conclusion that goes beyond it. You're not going to say, yeah, it's perfect, and it never is in real life anyway. Okay, so again, that scale, okay, is your guideline. That's my expectations, and the textbook follows these as well. So you're looking at, you know, positive or negative correlation, and then the strength based on the numeric value. All right, got one more example that I'll zip through, and then I'll let you get going.